Meet the GIMP, episode 45. My name is Rolf Steinert and I'm recording this in Bremen, northern Germany. I'm sure you have noticed the new music. It's made by John Paston in Chicago. He has made it especially for Meet the GIMP. I asked on CC Mixter for a little jingle to play between different segments of the show. And John made me a whole music concept. I'm just learning how to use this, so there will be some glitches, I think. And I have to say a big thank you to John. Before I start with today's segment about monitor and printer calibration, let me say a word about quality. This is low-grade stuff I'm showing you. This is stuff that you can do without buying further hardware and without putting a lot of time into it. The results are, well, they are good, but they could be better. And if you are not content with the results of these methods, then buy hardware and invest the time. I think there's always a way to do something better. There's always the better camera, the better lenses, but you have to draw the line somewhere. And I think this is good enough for amateur work. If you want to sell your stuff, then you have to go the way to full calibration and including profiles and so on. I will go into profiles when I myself have mastered that. And now, let's start. In our photo group at 23hq.com, there's just in the moment a lively discussion about seeing what the camera sees. It's basically a discussion about calibration. Calibration of the camera and the monitor and perhaps even the printer. In my eyes, most important point in this is calibrating your monitor so that your monitor shows you the same as others see on their monitor. Well, they need to have a calibrated monitor too. But if your monitor isn't calibrated, you'll see images different than me or somebody else, and you like your image the way it is, and we think, oh, what's he thinking about that? So, how do you calibrate your monitor? There are some hardware tools for doing this. I bought one, a Spider, but up to now I haven't really tackled that, and Joel has a very nice introduction into this on his website. Just go into meetthegimp.org and click on the link. But there are software tools for doing this. The easiest one is online. If you go to the website Cambridge in Color and look at the photography tutorials and go to Viewing, then you find a page with viewing advice. These three squares here are a first tool for that. If you squint at the image from a distance, you should see on this square here a slightly darker blob, on this square here a slightly brighter blob than the background, and this should vanish into the background. If this is the case, then your gamma adjustment of your monitor is quite right. There's a second test. If you look at these shadow details here, you should see a step from here to here, and in the brightness from here to here. If your monitor passes this test, oh, by the way, not by looking at the video here, but by looking at the page at cambridgeincolor.com, color in the English way with OU, then your monitor is fit enough for general use. There's another way to do calibration on the cheap side. This is Monica, a tool for Linux, but there are tools also for Windows and for Mac OS. I think the most common is Adobe Gamma. So, how does this work? You need this when Cambridge in Color says that you have a problem, and you can adjust this problem here. Let's look around a little bit. On top we have a staircase of black and white, gray, or black, white and gray steps, and these are different steps in gray, and you should see a difference between this and this here, and between this and this. Then your brightness and contrast of the monitor settings is about right. The second thing is you should see here a uniform gray area. If you don't see it, then your gamma is off. This is set to gamma 2.2. I'll tell a little bit about gamma in a moment. So, of course, this is not uniformly gray here, but if you squint through your eyes, if you close them and look, that you get an unsharp image, then it should blend into a uniform gray. And if it doesn't, you can use these sliders here to move it around. And well, I think you won't see it because you can't see my monitor. You see only the pixels in the memory buffer, but this definitely changes this pattern. Now this is black, this is white. So let me get this back, restore default. Okay. This program can store the correction values in your system files, and it can even change the balance between blue, green and red. It works basically in the same way. If you squint at these squares here, you should see one square. If you look exactly, you see here a green square, and around it a rectangle made out of black and green stripes. But well, squinting with the eyes mixes the black and the green, and basically here the same, mixes white and black, and you get the gray, the same gray that is here. So this is Monica, and I think all the other tools work in, well, exactly the same way, and depending on the system they store their values somewhere, or you can change them with these tools on the fly. You see here the heart of Monica, an image running with stripes from uniform as gray, like here, and going into whiter, even white, until we are here, and this here should be white, or going into black, and this is not here, is somewhere here is real black. The white and the black are mixing up if you squint at the image, not at this one here, but at the 1 pixel width image. Let me go back to that. So here, if you squint at that, these colors mix up, and they have to mix up to the same gray value with all the combinations in this for getting a monitor gamma of 2.2. What's this gamma? Well, if we ask Wikipedia, we get an answer. Gamma correction, gamma non-linearity, gamma encoding, often simply gamma, is the name of a non-linear operation used to code and decode luminance or tree stimulus values in video or still image systems. Gamma correction is, in the simplest cases, defined by the following power law expression, and so on and so on and so on. Well, let's boil this down to very simple stuff. You're looking at this image in front of you, at your video screen, with your eyes. Your eyes contain four different kinds of sensors. One type for black and white and luminance information, and one for red, one for green, and one for blue. So this system is anything but linear. It is off. It is way off. It is specialized for everyday use, so it responds well to overwhelming lots of light, and it is still workable in candlelight with very little light, and this works only with logarithmic answers. So it has to answer a little bit for very, very dim light, and a bit more for a little bit more dim or less dim light, and there has to be room on top for, well, the light in midday sun on a sunny beach. The next thing is your monitor. It's also non-linear. Linear, linear. If you double the voltage, you don't get the double amount of light out of it. The next thing is the whole technology. You have a camera which doesn't react linear to different amounts of lights. You have a monitor which doesn't produce light in a very good form conforming to the amount of voltage you put into it if you have a CRT monitor. And in between you have software to get all this stuff into line. So gamma correction is basically a correction for getting the wanted colors or shades of gray out of an image when you use non-linear technology and non-linear eyes to look at. And well, it's basically a definition, a question of definition, and this gamma 2.2 for monitors is the way to go if you want to see the images on your monitor in the same kind as anybody else. So if your images look on your monitor fine and other people's images look a bit off, then perhaps your monitor is wrong and you should check this out. If you want to do more than a hobby with photography, you need to hardware calibrate your monitor, and with that you put an electronic eye on top of your monitor, and it puts the software, accompanying software, puts colors below it and looks at it, and calculates a translation table for the different colors and the different shades of gray. But that is out of scope for this year. If you want to know more about color management, there is a lot more into it, and I'll go that way, I think, but I'm not there yet. I go to Linux Photography, the blog of Joel Connu, and I have often pointed to that, and click on his category Color Management. And there you see some entries about that, especially here about ICC profiles with a spider, and also this stuff explained. I don't print my images at home. I give them away to a print shop, and they use machines which print this image not with ink but with lasers on photographic paper. They face the same problem. Sometimes the images are simply a bit off. And for an easy solution for that, not high quality but good enough, the German Photographic Industry Association has developed a tool named DQ, Digital Quality. You see, it's a German website, therefore we have to have English words for this. Okay, how does this work? you get two images. First, there's one for roughly setting up your monitor, but if your monitor is set up accordingly to Monica or to the Cambridge and Colors website, then you will see that everything is okay. And then there is this image. This image is available in a resolution fit for your monitor and in a resolution that fits for a printing 13 by 18 centimeter print. And you just give this file to your printer and let him make a copy of it. And then you take this copy, check it first if the colors are right. If they aren't right, you can be absolutely sure that these colors in this file are perfectly. So if the colors are off, you can talk and have to talk with the people in your printing shop. If the colors are right, you go to your monitor, look at the other file, the file with monitor resolution, and check if they look nearly equal. You won't get the same result because a monitor is active, it sends out light, and the print is passive, it only reflects light, so the monitor image will always be brighter. But if you see the same image, if you think, okay, this is okay, then you can be sure that your prints will look equally to the stuff you see on your monitor. And if your prints look off afterwards, you can again talk to your printer. I often include in a batch of images this test image. Not to check on my monitor, I'm pretty sure that that fits, but to keep the printing people alert that I know about this stuff and that I will come back if the colors are off. And so if the colors are really off, the machine isn't really calibrated, and they see my batch of images coming through with this one between them, then they will recalibrate the machine and run my batch again. So this is a double tool, one for getting the prints. So this is a double use tool, one to keep your monitor straight and one to keep the printing people on their feet. I put a link to this page into the show notes. The background music in this last segment wasn't by John. It was courtesy of my neighbor's stereo at full blast. I think this was it for this week. Next week I'll go back to last week's show about multiple exposures and cover some variations, different ways to take these pictures and different ways to post-process them. And I'll show you a way to take pictures without a tripod. So if you like Meet the GIMP, blog about it, write somewhere about it where it's not spamming but informative. The subscriber numbers and download numbers are stagnating now, and I seem to have hit the ceiling with this. If you know something that I can do better, just write me a comment at meetthegimp.org into the show notes, or write me an email at info@meetthegimp.org. And so I say just goodbye, up to next week.
photocastnetwork.com, your photography resource in the potosphere. photocastnetwork.com